All right, here we go. Number 11 to 20. Boy, who is more excited than me right now? Cumulative review, number 9. Are we ready to get this thing on this show on the road? Holy buckets, I'm excited. All right, so remember, degree. For number 11, we're trying to say the degree, the leading coefficient, and the number of terms in each. All right, in each problem. So if I look at this problem, remember I determined the degree of my polynomial from the highest exponent. All right, the highest exponent. So if I look here, my exponent is 4, 2, 7. All right, and there is no variable here. All right, so this does not have a degree. So my degree here is 7. The leading coefficient, remember, 18 is not the leading coefficient. The leading coefficient comes from, if I were to write this in standard form, okay, it comes from, the leading coefficient is determined by the term with the highest degree. The term with the highest degree is x to the 7th, so my leading coefficient is 1. There are 1, 2, 3, 4 terms. Well, how do I know that? Because there are 4 things separated by addition or subtraction. Wow. That is pretty neat. Don't you think so? I think so. All right, so, sorry. Here we go. So what is the degree here? Remember, if I have 2 variables in a term, I need to add their exponents. So that my degree in this term is 13. Add the exponents here, my degree is 16. And here it's 11. So the degree of the polynomial is 16. The leading coefficient comes from the term with the highest degree. The highest degree is here, so my leading coefficient is -4. And there are 3 terms. It's exciting stuff. Let's keep going. Why not? Why not? Number 12. Yes? Okay, number 12, we're simplifying. All right, we are simplifying in number 12. So what I want to do here, this is PEMDAS. I want to think about my order of operations. I want to attack the parentheses first. So I'm going to distribute my x here. All right, and I'm going to leave this parenthesis, this set of parentheses right there. So x times x gives me x squared minus 3x, close it, minus x squared. Remember, when I subtract, it's like there's a -1 here. Be careful. 10x stays the same. Minus 2 minus x squared plus 3x minus x buckets. Let's make that red. Minus x squared. Combine my like terms now. All right, combining my like terms, there's a like term, here's a like term, and a like term. So, how many x squareds do I have? I have -2x squared plus 13x minus 2. I know it doesn't say this, but there are 3 terms here. Degree of 2, my leading coefficient is -2. That's neat. Now you can go home and tell your friends that, hey, what's the leading coefficient of this polynomial? You know, that's what I do on the weekends. That's what we talk about at the dinner table. All right, and by we, I mean me, myself, and I. So now, you got to just have some fun here. Now in this one, multiplying. So remember, when we multiply, it's similar to FOILing, except all I'm doing is distributing. I'm distributing the 4x to every single term in my second set of parentheses. I'm distributing that 4x to everything. So 4x times 6x squared gives me 24x cubed. It's okay to make fun of yourself, right? I mean, 4x times -7. Wow. -28x. If you can't, then no one will, right? -3 times 4x gives me -12x. So that should be a squared. All right. Then I want to multiply -5 to everything. I'm going to show you a little trick here, okay? You can do this, you can, it doesn't matter. All right, I'm going to show you a little trick here. I'm going to write, so I have -5 times 6. All right, that gives me -30x squared. Well, a little trick for you, I'm going to line the -30x squared right underneath the other x squared. Why? Because when I combine my like terms, it's like I'm adding straight down, okay? Negative 5 times negative 7 gives me positive 35x. Negative 5 times negative 3 gives me plus 15. Now, you don't have to do this. I also didn't have much space over here, so I kind of wanted to do it. Another reason I wanted to do that. So if I think about it, that's like an addition bar. There's nothing underneath here. That's 24. Oh, my goodness. What is going on today with this thing? 24x cubed, negative 28 and negative 30 give me negative 58, potentially, there you go, negative 58x squared. Negative 12 and 35 gives me positive 23x, and then the 15 just comes straight down. Wow. 4 terms. Degree 3, leading coefficient of 24, in case you were checking at home, or in case you were wondering. Factor. Factor. This is a SOAP problem. God bless America. SOAP. This is one of our special factors. Sum or difference of cubes. This is a difference. Okay? I have to think about, all right, what am I taking to the third power in my first term? What's being raised to the third power? Well, what is the cube root of 27? The cube root of 27 is 3. So I have 3, and the cube root of x cubed is just x. The cube root of 64 is 4. All right, now, so remember, first S stands for same sign. Here, squared. So let me write this out for you. It's A minus B. I'm seriously going to get so mad. A squared, oh my goodness, plus AB plus B squared. Same sign as the original, opposite sign, always positive. All right, so I need to square this term. I'm squaring the 3, which gives me 9, and I also have to square the x. Please do not forget to square the 3. A lot of people forget that step. Plus A times B, 4 times 3, 12. But don't forget to attach the x, because the x is a part of our A term. Okay? Plus, always positive. 4 squared, 16, all day. There's my factor. That's sick. Here we go. We are flying. So is that paper. 15. All right, for the next ones, we're going to go 15 through 20. You want to solve each quadratic, put a box around your final answer, and then write the method. All right, so you're probably wondering, like, well, why do I have to write the method? Well, our reason for asking you to do this is so you kind of pick up quickly, okay, when I see a certain thing, you know, a lot of people ask the question, well, how do I know when to complete the square? How do I know when to use square roots? How do I know when to just factor? All right, so we're trying to help you identify when to use each of these methods, okay, when to use each of these methods. Well, if I'm looking at this problem, all I have is an x squared term and a constant isolated on the side of the equal sign. Well, if this happens, might as well use the square root method. So that's the method I would put in that line. I don't have that line on mine. So divide both sides by 5, get the square term by itself. So I have x squared equals 8. Again, it's a square root method, so I have to take the square root of both sides to get x equals plus or minus the square root of 8. Well, remember, always simplify. This is root 4 times root 2. So x equals plus or minus 2 root 2. Wow. Boom. Here we go. Again, this is the square root method. 16. All right, so now, completing the square roots, or factoring. Well, I have 2 variables. I have an x squared and an x, so the square root method is out. All right. Completing the square usually happens when I have a trinomial, which I don't, so it looks like I want to factor. Remember, the first question you should ask yourself when factoring is there a greatest common factor? And there is. The greatest common factor here is 2x. I'm going to take the 2x out. I have 18x squared divided by 2x. Well, 18 divided by 2 gave me 9. X squared divided by x gives me x. Minus, okay, 32 divided by 2, I get 16. And the x divided by x is just 1, so I just leave it like that. Now, here's the deal. A lot of us will forget to write this term sometimes when it's just like a 1. Okay, remember, if I were to redistribute this term, if I were to distribute my greatest common factor, I should end up with my original. If you distribute your greatest common factor and you don't, recheck your work to see where you went wrong. All right. So now this is completely factored. Zero product property. I set each factor equal to 0 and solve for x. Divide both sides by 2, x equals 0. Add 16 divided by 9, x equals 16 over 9. That's a great circle, isn't it? That's so aggravating. This is getting real laggy today, you know? It's unreal. It's just unreal, isn't it? It's just unreal. Wow. Let's see, I got 4 more in 4 minutes. I don't know if that's going to happen. Got a battle. Actually, you know what? We're just going to pause it here. All right, we're going to pick up. Our next video was 17 through 20.